more participants. Right now we have, I guess, one person. So we might have to take a call. So I'm not sure if we
Okay.
could go ahead. So I'd suggest not to stream yet, and maybe we can wait for 5-10 minutes and decide.
Okay.
Yeah.
Okay, I checked the screen already started, but that's no problem. Uh, my colleague here will put the slider, will stream the stream, so we should have no problem. Can you see the stream on YouTube?
Sorry.
Do you see the stream on YouTube?
Yeah. Yes.
Okay.
So I think we could try those. Yeah. So we'll have shorter session otherwise, I guess. Sorry. All right.
Okay.
So I guess Prakriti, you could start.
Can you
Yeah, I
see
think we can get
the stream?
started.
So we should have no
Request
problem.
Ron.
Problem.
Yeah, so
We
in
should
this
have no problem.
section, we will talk about the work that our lab is specifically focusing on, like one of the
Do you see
projects
the
that is
stream
looking
on
into
YouTube?
AI in
Yeah.
education, and
Yes.
that project is
Okay.
titled as a Scholar.
So I
So
think we
moving
could
ahead,
try those.
the design and development of this project involves investigating the effect of augmented reality in learning and the development of spatial ability, and how can AR be taken forward so that the examples can be shown beyond the ones that are there in the textbooks, and how can collaborative and peer learning be brought forth using the constructivist approach of learning by doing, and the teacher as a facilitator and reviewer is is what we are targeting at. The age group that we are considering is basically the students from middle school level, for whom the abstract concepts in STEM education are being mostly introduced. And this seventh grade is what we have really looked into with the concepts in geometry. So the design basically involves the different types of learning activities, how the interactions are connected, and the different content creation based on the activities. The development is specifically looking into how the students and teachers sides interact, and how the networking of the digital labs is happening, and the provision for locally downloaded content. We are trying to scale it into across the different schools, ranging from urban and semi-urban to rural areas, and across any board of education, and across different subjects. We are gradually moving towards expanding the approach. So we have tried to conduct different studies at different stages to understand the relevance of the different interactions that are possible in AR to bring forth the affordances of AR in the learning space. So one of the studies focused on understanding the augmented reality interaction mediums that are suitable for the children of middle school level to interact with. So in this study, the objective was for us to explore the different types of possible AR interaction mediums that are there. We tested three interaction mediums along with a control medium where only 2D image was given. So in the three types of AR interactions, the first was that of draw and annotate, where the students could draw virtually with their index finger acting as a pencil on the screen. The tangible cubes, marker cubes, were provided to students to interact with the virtual object. And the third type of interaction involved tap and view, where using finger taps and by moving around the virtual object, they could interact with the 3D projected object. And then we tried to investigate the creative use of augmented reality interaction mediums to answer a few open ended problems. And also, we investigated the spatial reasoning skills of the participating students. So, this was the entire experimental setup in which we conducted the study. Moving forward, the task design involved four different tasks, which were based on four different topics of mathematics from seventh grade syllabus. The topics were that of area, lines and angles, symmetry and congruence, and visualizing 3D solids. We had different learning goals for each of these topics, and these learning goals were again based on what was being popularly taught in the classrooms. Talking about the methodology, there were 12 students of 7th grade considered for this study, and we had a balanced Latin square design for task and augmented reality interaction medium distribution to each of these groups, including the control group sessions. And we then try to evaluate how creatively they were able to respond to the questions that were put forth. We considered the factors of fluency, flexibility, and originality. And based on that, we were able to derive the creativity as categorized on the basis of the groups that were participating, the tasks that they were performing, and the different AR interaction mediums that they were using. So, based on the interactions, one group could be seen being highly interactive in the entire session, and they responded very creatively. That was group two. Um, then, or based on the task on symmetry and congruence was something that again led to students answering the questions very creatively. And as per the use of augmented reality interaction mediums, draw and annotate and tap and view were the two interactions that the students were very well versed with while interacting with the AR application that we had provided to them. Based on the results from this study, we had then worked upon implementing those interaction mediums into the different topics of mathematics in grade 7 syllabus. One of the topics chosen was that of lines and angles using augmented reality. Yeah. Are you able to see? Which slide are you able to see? Are you able to see slide 11?
12 now.
Are you able to see the figure?
Now it's 11.
Amarnath, can you go back
Yeah.
to slide 11?
Yeah, it's at 11 now.
Okay. Yeah. So this was the entire design of our application where we wanted the students to learn to identify the angles in their surroundings. And for that example, we took the 3D object of house and we superimposed in their real environment so they could move out and get into the house and explore it from within and outside. And they were then asked to mark the different types of angles so they could find the right angle, acute angle, obtuse angle, and the different pairs of angles in that. Yeah. So then we tried to test it in the lab settings as well as classroom settings. So this entire experiment setup is for the lab. Yeah, moving on. Next slide, please, Amana. This experimental setup is that of a classroom environment in which we had requested for an open space, and the students then use the tablet, and and they experience the markerless AR implementation, in which you can see the house got superimposed in the real world space, and then the students were interacting to find the different angles. So the students participated in dyads as well as in individual levels. So we tried to have a comparative study to understand how the two behaviors were different. Moving ahead. So, uh, towards the dimension of learning of cognition, we found that there was no significant difference in the scores for performing AR learning activities individually and in dyads. Whereas there was for the dyads, they performed significantly higher after interacting with the AR-based module, and there was no significant difference in the performance of those. There is an echo. Yeah, so there was no significant difference in the performance of those who solved the AR learning activities individually. Then we also evaluated the learning, like from the dimension of learning of considering the emotion factor, the motivation of the students in learning and using this application, and the overall motivation level score was that of 3.99 out of 5, which was considered to be quite high. We also tried to analyze the different learning behavior of the students, and uh, we coded the different interactions of the students, which were categorized based on.
One second.
Yeah, yeah, yeah. Slide
Yeah,
16.
this one.
16. So we coded their interactions based on three major categories that were peer involvement, teacher prompts, and AR interactions. And based on that, we were able to derive some key interactions that happen and that helped us in reflecting upon the design of our application. So we majorly found that the students in the dyads helped each other to mark the angles by correcting each other. So this was one kind of peer involvement that was majorly seen. In terms of teacher prompts, the prompted majorly to help the students in scaling the house by sliding the two fingers. They would otherwise scale the house by moving back and forth around the house. And as per the AR interaction, the feature of uh, AR was explored by the students by moving around the house from all the sides. So these were the key interactions that were majorly being
in
followed
the
by the students. Moving ahead. Yeah. And so another kind of interaction was tested with the topic of visualizing solid shapes, and different iterations have been tried upon. So the interaction of tap and view has been worked upon for this topic, and the subtopics of types of 3D shapes and vertices, edges, and faces were explored in the first iteration of this topic designed in AR space. Next slide. This was the entire experimental setup for the first iteration, where the students participated in groups of 4. So we were also testing which was the ideal group formation for the classroom experience, and based on these two studies, we were able to derive that the students were more effectively working in dyads than in groups of 4 or groups of 3 or individually. Next slide. So we also, like with this study, we also reflected upon the visualization skills that the students were able to obtain. So they were with the help of the 3D objects that were shown to them, they were trying to create the different scenarios, like that of showing sun on top of a mountain using the uh, pyramid shape and the sphere shapes, and making a palace, or Troy helping create the scenario of a Troy train crossing a forest, or making a hut using all these 3D shapes that were superimposed in their real world space. Then, about the perception of learning, they emphasized that they were able to learn more about the 3D shapes, and they were able to make any object with those 3D shapes. And that helped them realize that many things around them are made of these shapes, and then these tend to get modified. As per considering the usefulness of the application, the students considered it very helpful for those who are beginning with this topic of visualizing solid shapes, and it added fun element to the activities that they were doing. The different types of activities made the application interesting for them. And the challenges, there were several challenges which we again tried to deal with in the second iteration of the design. Next slide. So with this activity, we were also able to evaluate the learning impact. The learning impact was basically there was a significant difference in the performance of the students after using our application in collaboration. And yeah, so we then designed the second iteration, or the framework of which involved having different stages of learning, where for any topic that is being taught, there are three stages. The first stage would involve the exploration in AR space. Then the students would have some learning activities in AR. And in this third phase, they would have reflective questions in AR and a set of reflective questions without having AR. And we then also define the role of the teacher, the role of the students, and the different active learning strategies that can be incorporated in each of these stages. So we will show you a brief demo of what we are looking at and what has been designed.
Can I play?
Yeah, yeah.
Yeah, so I'd like to point out something. So while placing the vertices on the ground, so one kind of micro interaction we added was to have like a larger range for triggering the placement. So usually when it comes to diegetic AR elements, it's better to have some extra range within which the interaction would work. Otherwise, stabilizing the phone and trying to interact with a smaller element may not be ideal. So yeah. think we could switch to the video again. That is kind of a gist of the current implementation. Oh, okay. So yeah. This is like an offshoot of the existing project. So we started this after COVID and lockdown, and we figured it may not be able to, we may not be able to take up the experiment to the physical location. So Scholar Remote is a project where we try to bring our learnings to a social AR space and see how we could have the teacher-student interaction uh, in mobile AR. So we have the experiment is yet to be conducted, but demo of the system could be shown for now. Is it pause for everyone?
Yes.
So that kind of sums up our work with Scholar. Um, so Scholar Remote is still ongoing, and we are looking for participants for the study. But yeah, we have real-time interactions with shared AR objects and um, um, a space where they can communicate with each other spatially. So hopefully we'll have more results next time.
So Marina, we wanted to ask you here at this point. So, you were talking about remote AR in the beginning of the session. So, can you just highlight more onto the work that we have pitched in, and what thoughts you have about this work and the work that is going in your lab? Was I audible, Marina?
Yes, I
Yeah,
heard
yeah.
you. So you want me to tell what I'm doing?
Or rather, your impression of our work and
What is my impression? Yeah,
yeah.
it's very interesting. I'm very interested in connecting teachers with the pupils. So do you intend to make it open source to be used by anybody?
Um, Not yet, because we are still researching on the whole concept. But so it's simple to build this sort of solution. So hopefully, once we have more features added and have like a solid idea about the concept, we could put it out for public use.
Okay, and the content is created by both by teacher and the students, right?
Yeah, so we get instructions from the teacher and try to design activities around. But so yeah, ultimately the teachers contribute to the sort of content that we present in the application. So we'll have to build up a custom application every time, although. So compared to, sorry,
Yeah, please,
yeah, go on.
please. No, I
No,
was
so-
just curious what environment do you use to program that? Do you use Unity?
Yeah, so this was built in Unity, and the networking was done in Photon. We used a SDK called Photon for networking and voice communication, which I guess might be used by ILRN as well. I'm not sure, but could be the case. So compared to your architecture, where you had a head-mounted display for the student side, how do you suppose handheld mobile AR system might fit in? So would you still prefer a HMD, or did this give you any ideas about using handheld mobile as well?
Yeah, using an HMD is still has some problems from the tests that we have done. You cannot use it for a long time.
Yeah, that's true.
So from this point of view, probably a tablet is preferable for a longer session, for a longer learning session.
So yeah, that's kind of one of the reasons we chose tablets over HoloLens, and also because it's easier to scale up a solution which is mobile based, considering the availability of handheld AR. So, yeah, Pratiti, do you have anything to add? All right, so I guess we can conclude the session. Early.
Are you
So,
able to hear?
yeah.
Yeah. So Marina, so do you think what all problems do you think HMD has as compared to tablets, or tablets are better to use, or how do you place the two mediums?
I think
Especially when it comes to the context of small children, or say students who are from middle school levels.
it's difficult to wear it for a longer period of time. I think for short session it is fine, but if I don't know if it's more than half an hour, I think it becomes difficult to wear it.
Pratiti, can you try speaking, or
Yeah. So, yeah, you were saying something, right?
sorry?
I'm getting some echo, so the voice is not really coming up well.
Okay. Wait. Yeah, I'm muting. Or okay, otherwise I guess we can wrap up the session and yeah, we can discuss more when we have like a better idea, or if you have any doubts, so you can reach out to us as well.
So, Marina, do you have anything to add on to the experience of this session, like this
Or
whole
any
entire
doubts?
workshop?
No, I don't know what I can add.
Maybe
Yeah,
you can reflect upon your experience, like how did the entire first session of the workshop go?
I think I have a technical problem. I'm not hearing very well. I don't know if it's from my side.
We can hear you. Can you hear me now?
Yes, now it's much better.
That's good. Towards the end of session, usually we can use the clap tool. If you just press F4 and then we can clap.
okay.
Okay, thanks.
Yes, thank you. So,
So,
let me try.
can we have a picture?
Yeah.
And one of the student volunteers take a picture of the session. So maybe all of us can come in front.
Near the board.
Yeah, near the board, presentation board. So student volunteers can also join in.
Yes. Yeah. Thank you for attending this session. Hopefully, it was useful to you guys as well.
Has anyone been able to click the picture, take the screenshot?
Yeah, I asked Gada to look at them so then they can appear in the stream.
I don't know if Jader wants to be in this because if I take a screenshot, then I can see you.
Okay.
No, but he can look at them without appearing in the screenshots.
Have you managed to take a screenshot, Jules?
Yeah, let me try.
Okay, that's good.
All right. So thanks everyone.
Thank you,
Yes.
everyone.
Yeah. We can
for
conclude.
joining.
Yes.
We can maybe end with a nice dancing move.
Yeah, and we can end the stream as well, I guess.
Huh.
Okay, so my colleague here took the screenshots. To whom he needs to send the email.
Can you send this on the chat?
Yeah, let me try.
You can click the computer file to upload beside the smiley face.
So he just saved the screenshot. He tried to upload in the chat.
We got that. Thank you.
All right.
Yes, thank you.
Thank you, everyone.
Thank you.
Thank you, Marina.
Yeah, thank you, Marina. Feel free to reach out to us if you have any questions.
So we will close the session here then.
Yeah, I guess I'll sign off. Yeah, thanks to the student volunteers again.
Yep. Thank you, everyone.
Okay, bye guys.
Bye-bye.
Bye.